we should have our solutions by now. What are our x values? What you have, you'll get x is equal to negative one third,
Yes, sir.
and x is
Yes, sir.
equal
And
to
x is
3.
equal to 1. What? Sure.
Oh, x, yeah, is 1. Sorry, why did I put that
Okay,
1?
sir.
Yeah, he said 1. X minus 1. Yeah. Yeah, so you'll get that, and x is equal to 1, right? Great. So we have our final step, step 4. Yeah, so what's step 4?
So we're going to substitute the value for x.
Yeah, and why are we doing that?
Ah.
Remember, we were asked to find the stationary points, not this, not the x value alone, the points. So we need, when x is negative one third, we need to know what is the corresponding y value. And when x is 1, we need to know what's the corresponding y value as well. So what you'll do, we go back to the original function that says y is equal to, so we find y values. Value or values depending on, eh? So it says y is equal to, and again, I'm not going to do this. You have to do your substitution and work it out, right? I am more interested in the steps, the algebra, the computation. I expect that you can manage that, right? Is the steps is what are important here. Minus x plus 7. And I always say one thing to all my math students: you're a math major. And when it comes to simplifying things, when it comes to these substituting and stuff like this, no excuse. If you find that you're weak in your spare time, you have to work, right? So please substitute negative one third for x, find the corresponding y value, then substitute 1 and find the corresponding y value. 2 minutes for that as well. Shouldn't be taking so long to get this done. So can someone please give us the answer quickly, please? Just quickly, please.
So what I got is when x is equal to negative one third, y is 2.
2. Okay. Uh-huh.
And when x is equal to 1, y is 7.
7. So let's see. The one from, so let's see this one. This one we can work this out quickly. 1, I think 1 minus 1 plus 7, right? So this plus 1, so it will be 6. Thanks very much, miss. Right? Yeah, so this one will be 6. Does anyone else have anything else? I did something wrong. So let's, but what I really want you to understand, right? All of this here that we're doing this working out, this is not the important part this evening. So I hope you don't get me wrong, right? The important thing right now is that I need to know that you understand this, that you understand the steps. These are the steps. Everything between the steps is totally up to your ability to simplify. Am I clear to anyone? Echo. If you're finding that you're having a difficulty probably factorizing, differentiating, simplifying, then you need to work on that. Right? All right, so let's see here. So 1 minus 1 minus 1, right? So you're saying 1 from 1 would cancel out as 0, and we have negative 1 plus 7, right? So we should get 6. Do we all agree with this? My mind is not really settled. I have so many things to do, and babysitting two big ones here. Trying my best to keep them quiet, dealing with them and everything. So I genuinely checked it back. Three nines 27, so this is 3 over. Why did I do that? So this will be minus 3 over 27, 9 over 27. So all I did is to make equivalent fractions. So this would be 1. So that would be minus 4 over 7 plus 9 over 7. So it should give us 5 over 27. Is anyone else working this thing out? Teachers?
Sorry, Ron.
Go ahead.
No, I gave my already.
Yeah, I really don't understand what's happening. People are now something wrong. That's what I need. And to be honest, I didn't plan on working these things out, right? As I said, the steps are the important things. Negative 1/3. Yes, 3 nines 27. That's 3 3 is 9, negative 9. Negative by negative is a positive. Times 3 times 3. So Nandrani, you check back your answer? You check back your work, eh?
I'm going through it now, sir, because you multiply the cube by the whole fraction.
Remember, negative 1 cube is just negative 1 times negative 1/3 times negative 1/3 times negative 1.
Yeah, well, I just replaced the
Okay.
cube. Yeah, 3 ones.
Oh, I understand. So I'm just waiting for someone to confirm what is the answer for this part, and then we can move on, right? 128 over
178.
178.
178, 27. Yeah.
Okay. And when you divide that, oh, so it's negative 11. Okay. Yeah. But I'm sure, though, our answer has to be a positive answer because those are just fractional values and the 7 is positive, right? So you could probably check it back.
It's positive 178 over 27. That's when you add the 70.
Oh,
So the part that you have, you got a part that I think it's 5 on 27.
yeah.
I'm getting negative 11 on 27 there when you work out that piece. I don't know if anybody got that.
It's 5. They want nonsense.
Is
Yeah.
it 5? 5
Yeah,
on 27.
yeah. As the
I'm getting
fractional
11.
part.
Yeah, I'm getting negative 11 on 27 there.
Oh,
I don't know if anybody got that.
So just ensure, right? I can see how you can get that. Now just ensure that you put the negative 1/3, then the cube.
Oh, yes.
Yeah.
I saw that. Yes. That's why I was thinking. Yes. I get that. Good.
So what I'm doing, I'm still waiting for the confirmation. But I'm going to show you the graph as well because I really want you to see something. So I'm in GeoGebra and I'm looking at the function, trying to construct the function minus x. And it has plus 7. Great. X cubed minus x squared minus x plus 7. Well, so let's see. Let me see if I could zoom in. Oh boy.
Yes, sir. It's 5 on 27. That's correct.
All right, good. Thanks a lot. So here we're seeing that, and I hope you're following. So this is the curve, right? And this seems to be the one of the points. Let me go to point, yeah. Somewhere around here. And this seems to be the other one. We won't get it exact. Yeah, so we see clearly that 1 and 6 is one of the points. Can everyone see that there?
Yes, sir.
Right, and the other point, I'm trying to pull it to 0.33, but it will be a little difficult. But as you can see, it's 7 and a little fraction, right? So negative 1/3 would be like 0.33, and we see our y value is like 7 with a fraction. So that 5 over 27 would work out something around that, right? So I really wanted you to see it here because the next and final thing we have to do after we find our points, so our answer here would have been 7 and 5 over 27. The next thing we have to do, we have to say if it's a max or a minimum. Are you following? Yes, no? We have found the points. These are the two turning points. But now we need to say if is it a maximum, is it a minimum, or is it a point of inflection? Can anyone tell me how we can determine what it is? Five is to determine max, min, or inflection. So this is where we use the second derivative. And this is how we write the second. B square y. So can we get a second derivative of the function quickly? So this is the first derivative. What would the second derivative be? You should have it written down there. So someone please tell me what's the second derivative. X minus 2. Wonderful. Right? So we can use the second derivative to determine whether a point is maximum or minimum, or a point of inflection, right? So all we're going to do now, we substitute our x value here. So we have two x values when 6 negative 1/3 minus 2. Work that out and please let me know what you get. So we substitute that negative value there in the second derivative, or x value in the second derivative. What do you get?
-4.
6 times negative 1/3 minus 2 would be 3 into 6. 2, so you have -4. Wonderful. Good. And then when we substitute 1, the other x value, into the second derivative, what's your answer?
+4, sir.
Positive 4. Right? So here what? When the second derivative is negative, you have a max. And when the second derivative is positive, you have a min. So this is one way that we can determine the nature of the point. So we are saying that at this point here, it's a maximum value. So even if I didn't go in GeoGebra and look at the curve, once I find the second derivative and put in the x value, I can know whether the point is maximum or minimum. So if the answer that you get when you evaluate that second derivative, if it's negative, it's a maximum point. If the answer you get is positive, it's a minimum point. Is that clear with everyone? Let's go back to GeoGebra and conform. Yes, so you can see clearly here at -1/3, it's maximum, it's turning upward, and at +1, it's minimum, it's turning downward, right? So that's how we determine whether a point is maximum or minimum. That's one of the methods we can use, and the other method is looking at points that come before and points that come after, but that will take up a lot of time. I had discussed this in a previous class.